on the left on this, isomorphism group over K. Right? And look at, that's why I may have mentioned this, I think, in Korea. Look at this, I forget how to write this. When you take a set acted on by a group, you look at the set of orbits, let me call it this now. Orbit space. Okay, so this is acting on here exactly by automorphisms in the sense of the differentially, as I talked about, this is the Galois group acting on the solution set. Okay, in intrinsic fashion, defined over K. Look at the orbit space. This is a definable set in the sense of quotients. It's a definable set. It's of imaginaries. It's a definable quotient. Okay, so by elimination of imaginaries in DCF0, this is actually a definable set. This definable set is fixed pointwise by automorphisms fixing the constants. You can check. So therefore, it's in bijection, K definably, with a set of tuples in the constants. And this embeds into C to the D, for some D. And the map is simply this, right? Let's call it I. The map is F of B is I of the orbit. Use the relation imaginaries. It's precisely I of the orbit. So it's a simple. The point is very important actually that the Galois group here is a definable group. It's not usually in model instability theory you get type definable objects. These will crop up in my next talk, which I'm not sure I can do. I can give. But this is a definable group, and definability of the group, of the Galois group, tells you actually this is just definable map rather than a type definable map. In general, these will be type definable maps. Okay, that's F. This is F. Okay. Now, what do we do? What do we do? As I said, we have CY is an elementary substructure of U, G, U. And we've got this map here, zero definable function. So this zero definable function has a meaning up here too. Look at the formula defining it. Look at the same formula defining it here. Call it F. And F will be, so this is a big algebraically closed field. This is plus, together with the U point of an algebraic group. And F is a constructible function from this to some power of this. Constructible over capital K by the whole setup. So look at F of the identity. Yeah? Is going to be in K to the D. Because F is definable in algebraic closed fields over K. And identity is identity, right? It's zero definable. Well, over CK, right? Now what this means, it means that, remember I had this O, the image of, right? So it means that, look at O upstairs, O of K as a point. This is a definable set in differential in algebraically closed fields. Quantified through definable. So OK as a point. And if I choose an A in O of CK, it does the job. If A is an O of CK, then let B in Y be such that F of B equals O equals A, and so type of B over K and A implies type of B over K and C, and this implies the constants of KB constants of CK with A This is everything you want. A equals CK. I said before, remember I said before that generally, the constants of KB is the constants of K adjoin FB. I said that before. Always, whatever B is. But in this case, F of B is in CK. So that disappears. So that does it. Okay, and so the key is to reduce to just, so key things, this interpretation omega and this F. And H, the Galois group, of course, plays a role. But the other interpretations, omega A, do not play a role here. And explicit role, and for part two they play more of an explicit role. Also in part two, what's important in part two, let me just say one thing for part two, an interesting fact for part two, one interesting observation. Interesting thing. Let G be a groupoid, say a connected groupoid. Connected means for every 2 points there's a morphism between them. It's not empty, right? The morphism is not empty. Connected groupoid, definable over some field L in ACF. Take a definable, it's like a special case of definable group, for example. Definable. Now a definable groupoid. So you want to know what this is, and the paper describes all these things. I mean, in quite, okay? Right, so you have a definable groupoid. This means it's like an algebraic groupoid. The objects are an algebraic variety. The collection of morphisms is a uniform family of algebraic groups, and they're principal homogeneous space, etc., etc. Right? So you can imagine a definable groupoid, or an algebraic groupoid, defined over L. Now it's defined. It's like a variety. It's defined by quantified free formulas. So I can look at GL, which means the interpretation of those formulas in L. It's also a groupoid, in the sense of in the structure L, defined in L. If L satisfies Serre property F, if L has Serre's property F, then this groupoid has finitely many connected components. And this is important. This is what is important to one of the. This is how one uses Serre property. It's more or less this Galois cohomology stuff. The Galois cohomology is preserved.
That's where it is.
This Galois cohomology is preserved because you think about what's going on, and all these things are sort of homogeneous. Yeah. You think about this, and there's some. Something is the collection of. You take you take L, for example, you take a certain point in L, A in the object. Now, HA, the group HA, morphism, will be not empty. We'll get an identity, for example. This will. But somehow the different components give rise to elements of H1, Galois cohomology of HA. Right? And so the point is this is finite. First Galois cohomology is finite. For a Serre property, that's a key thing. But anyway, this definable groupoid plays an important, has another role. So maybe it's time to stop. Okay. So I thought, things are written down. I tried to make an effort to write things for a general audience here. But I tried to make a big effort to write for exactly this audience, for Phyllis. And Alexei and William and Richard. I mean, for the differential algebraic brothers and sisters, if I could use that expression. So it was written for an audience of differential. Okay, so I tried my hard, but we define interpretations. Everything is defined here.
So the upshot of all this is that the whole machinery that you develop here applies not only to strongly normal extension, but theory, but also parametric strongly normal theory?
Yeah,
Is
I
that
mean,
what it is?
yeah, this will apply in that context too. But the main thing is that this is a kind of substitute for the objects that I described, are a substitute for the Tanarchian, for a certain Tanarchian category, in the non-linear, outside the linear environment. Now, Moshe did write a paper called Tanarchian Categories and Model Theory. I don't know if anybody read this paper. Did anybody here read his paper in Transactions AMS? Did you read his paper called Tanarchian Categories? Did you read his paper? It's connected with your thesis, actually, isn't it?
Yeah.
Did you understand this paper? Was it? No, seriously.
What do you mean by understand?
No, did it make? I mean, because I mean,
Parts of it made sense.
Good,
Yeah.
good.
Yeah.
Anyway, so he has his.
Parts of it are very well written.
Really? Okay,
Yes.
good. I didn't. I mean, I dealt with it at some point. I'd look at it, but I'm just simply saying there is another treatment of the Tanarchian theory by Moshe. Well, this is independent, although related. Okay.
But you didn't put the time interest part into this paper.
Me?
Yes.
No.
And why not?
Pardon?
Why not?
Because I didn't want to focus on. I didn't want to. I don't know why. I mean, there's one can look. Because I think it's a routine general. I think it's a totally routine generalization. What is less routine is doing this kind of thing. What does it mean for this general Galois theory, our Galois theory, which is locked over the constants?
Yeah.
And so there you could ask what's going on, and there can be. I mean, in fact, Freitag actually asked this in Korea, and I think one can formulate. You have to look at one can formulate statements. And it's worth looking at what happens for this where it's less routine. It's not routine. In parameterized theory, you simply replace the constants by some other differentially closed field, and so it's not. It's okay. But
Foundation.
that's what you were doing. Exactly. You first did it for the. Anyway, you did the same thing. The paper with.
Well, the time interest case had many more details.
Did it? That's because the Tanarchian theory is you have to adapt it there. Here,
Right.
there's nothing to adapt. It's simply identical. It's identical.
It's the example.
It's totally identical.
Variations.
Yeah.
Yeah.
Do it several derivations. Do it in some over some. You interpret. You have something over a field of. It's the same business. You have something linear. Several and now the constant's role is replaced by some other differentially closed field in fewer derivations. And it's. I think it's maybe a student could work it out, but I don't want to really do it myself.
Foundations follow exactly.
Yeah, I think but the other more general Galois theory maybe that you have to even formulate different statements. For there, there's this identical statements, and then there's a translation. But the other case is not a translation; it's different objects. So one has to see is it meaningful there to say something interesting? Now, one question is, does this whole stuff say something interesting? I mean, there was a question. Where did the question come from, by the way?
No, because most useful ground fields don't have differential closures in them.
Yeah.
Absolutely
So
important.
Q of
Yeah.
T and so
Yeah.
on. So
Yeah.
can you do this over fields
Yeah.
that are in practice?
Do what?
Can you give Galois theory?
Yeah, I mean,
If you're in the spirit of Galois, you start with known functions, you want to know what you get. If you have to say, we start with a differentially closed constant field. So if you're interested in the nature of the functions you have to adjoin, and you
Yeah.
finally get to something like the incomplete gamma function, you really do not want a big ground field.
okay.
That-
So,
that
yeah.
is- So the
I mean,
descent there.
algebraically closed. I mean, not algebraically closed. It shouldn't be algebraically closed.
No, there's
Not that either.
What?
Requirement
No.
of Galois in prime interest case for the constants.
Yeah.
Yeah. Okay. Right. Yeah.
So like Q joins some extra variables.
Yes.
There are-
Okay. So maybe if you do that, I see. So maybe I'm see. So it's more than what I'm saying. I'm sorry. Maybe in Patrick's case, maybe I didn't read that part of what you did. So just maybe I will not comment
No.
before. But maybe there's things going on I
Very
didn't understand. So okay. In fact, I'm sure there are. So apologies. Okay. I'm sure there are.
But how restrictive is this property? I mean, as it applied, for example, to parametric or partial?
No, but now what the set probably gives you. The set probably gives you. Yeah, you can do it. You can develop this in the same. No, I'm not sure what happens actually in the parametric case for the Serre property. What are you looking at now? You're looking at something else. And so I'm not sure what goes on. That will be interesting.
Yeah, I mean,
But the Serre property is only about the existence of a
Finally, an extension of the
no,
equation.
it's not normal extension. What does it give you? It's not a normal extension, which also is real. Now, what does that mean? I don't know what that means. For example, you fix say, real closed fields, which are constant, CK. K is real. Then you get a PV extension, which is also real. So what? What does that imply about anything? I don't know. So I don't know what that means to get, so it's something they did, Heito asked about. I don't know what, why, so what? And maybe there are implications for, as I said, Singer's theory, CODF of this. So this is the question. Suppose you have a real, is this relevant to anything that you know, that you can choose actually the PV extension to itself be real? Is that something interesting you for any reason, or anybody for any reason?
I think so.
Why?
Well, it's good to know properties of what you're getting.
Yeah, and it's good to know lots of things, but the point is that it's good to know, but...
For CX will be better.
Yeah. So that's what I'm saying. I think there's implications for this that maybe I haven't thought.
Maybe single.
I didn't think about so much.
Yeah, I think this is beautiful though. Why not, for the parametric theory, why not replace Sayre with the vanishing of the first cohomology group, constrained cohomology of Colton? Are they equivalent, the Sayre condition, to what sort of facts about...
That we know about
Colton
Sayre.
has a beautiful description of the first cohomology groups for constrained cohomology that fits right in here, exactly. When it's finite, when it's this, when it's that. So you could get rid of the Sayre condition if by exploring the equivalence between that and various factors.
So it's about this it's something about constrained gamma cohomology. That's what it's about. Constrained gamma
that, which somebody should do.
So there'll be some statement
Beautiful
like
theory.
that for this.
Ray Hoblu was interested in it, Michael was very interested in it, Singer was very interested in it.
So again, in the parameterized case, you do it so that here is the difference between field and that's algebraic closure. Now, the parameterized case usually is differentially closed, but you do it.
Yeah, but doesn't.
You do it again, assuming EC. You have the EC condition.
Yes.
What is your condition?
Yeah.
If CK, which is now differential field in one derivation, is EC in K,
Right.
then again you do it, okay?
Yeah.
And now that part of it,
Very nice.
I think that part of it, I imagine, from this point of view, I would think is routine. Maybe I'm wrong. I didn't check. I would think it's a direct translation, but maybe I'm missing something. That's my first approximation, right? But because this point of view, one doesn't have to redo the Tanarkian theory, simply...
Well, given the Tanarkian theory, this result restricted to the linear case was routine. It was just like half a page.
Yes, I know, I saw that, yeah.
But with the Tanarkian theory, for the parameterized case, it was a 90-page paper.
Yeah.
What are these tier extension stuff? Was that something? Maybe we can talk about this. We'll talk later about that. Yeah. Oh, okay. So possibly I'm missing. So I'm sure I'm missing something. But I think checking this in the parameterized case would maybe be now worthwhile if you think there's such a big difference in the 90-page. Yeah. Okay. Thank you very much. Thanks a lot for the.
We move to 6417.
What about
7 minutes?
Can I get a cup of tea on the way or something?
Yeah.
Not on the way, but
The conditions that physics.
Go downstairs.
What?
Go downstairs.
downstairs is still open. Yeah, it's still
Downstairs
open.
should
right?
be
Yeah,
open. Downstairs should be open all the time.
Even upstairs should be open.
But
Yeah, that's right.
upstairs is a bit of a long way. I said a long
No,
way.
this
No,
is
there's
faster
no way.
because
Yeah, it's
because
faster.
8 minus